sorry that we are changing the time of our presentations from Thursday, because Thursday is going to be a reading day, and we want to get advantage of our distinguished visitor here. So I'm very pleased that Matt's with us here. So let me properly introduce him. He's a certified European professional engineer who has worked with road pavements for more than 20 years. He's active in a number of technical committees within Sweden and as well as international. And he is the chair of the Swedish Association of Laboratory and Field Methods for Testing Road Materials. He was visiting Minnesota DOT as part of an exchange of information. That was in 2009. So he didn't miss the cold weather in Sweden by being in Minnesota. And we are all welcoming him here in Illinois. You will hear him as a keynote speaker also on the Bituminous conference. So he was graciously accepted to talk to you. And I just wanted to mention here that there's some other people from the DOT and other places now going to be watching their presentations who cannot physically be here.
Okay, great.
So, welcome.
Thank you.
Yep. Please join me.
Thank you. Thank you, Ahmad. Thank you for those kind words, and also thank you for inviting me to come here. It's a privilege. And I had a tour also this morning, and it's been really great to be here. You have a very nice facility here. For those that participate online, they might be able to write questions for me, I guess, and it would be nice to also know if they could interact with us. Yeah, so let's get this going. Imad asked me for 2 presentations. I've tried to combine them into one, but we will make a quick stop between the 2 presentations. They're a little bit different, both. But the first one is going to be on the performance of flow mixing technology in asphalt concrete. The second one is going to be about the asphalt rubber project that we have had running in Sweden. My title, in Sweden we're not that fixated with titles. You will see on different presentations that I have different titles. That's because I also have them. The latest one is that I'm the National Coordinator for Road Surfaces. So, and we're trying to figure out what that means. Just a quick, where are we? Where am I? You know where Sweden is on the map? It's way up there. So, and if you look, you don't have the polar circle here, but it's actually some parts of Sweden have that fantastic midnight sun, which also means that this time of year it's the midday darkness. So the sun won't come up until February, probably. That's not the densely populated area. If you're interested, Sweden is population of almost 10 million people live there. So it's quite good size. I looked at Wikipedia. I'm not sure this is correct, but is it Illinois 13 million people or something? Something like that. Size of Sweden, probably in the range of 3 times as big as Illinois. So you get. We have some specific challenges compared to other countries. We do use a lot of studded tires. It's mandatory to use winter tires during the winter. And for a lot of people, that means studded tires. 70% of the cars, 70, uses studded tires. It's been decreasing, and the news just had an article saying that the amount of studded tires is decreasing a lot, and that was 2% less, so 68%. So we're during those frozen months, we have a lot of studded tire. And studded tire causes wear, so studded tire wear is a big issue. We also have, well, winter conditions, and we also have a lot of heavy trucks. Safety has been one of the main focus areas during the last, I would say, 15 years. And we've built a lot of these roads with medium barriers or cable barriers, crash cable barriers. So the head-on collisions, there is no more. This is one of the safest road networks we have, safest roads. But all of a sudden you have channelized traffic. Everyone is driving in the same wheel path, and you can imagine what that does to the load of the road. So we have issues now, rutting issues that we gotta try to control. Also, maintenance during, if you have a cable like this up and you want to do maintenance activities, you gotta put that cable down in order to get trucks in or out, to remove material, get new materials in there. So there's a lot of specific challenges for us. This is another one, that the increase of traffic of heavy goods, the conveyance of goods all around. And in gray here, you can see the maximum allowed gross weight. As of now, 60 tons, that metric tons, that is equal to 132,000 pounds. So it's pretty heavy trucks we have. And we also have special provisions for even heavier trucks. So we might be up in the range of 90 in near future, or if that's only going to be on special allowance. And if we look at the paving market, and mainly, I would say 99% of the pavements, they're bituminous pavements, asphalt pavements, less than 1% cement concrete. So we use a lot of those asphalt paving. And the season for paving is short. It's between May and October. It happens that we also start pave during November, sometimes even in December. It's not recommended, not allowed, but still we have a fiscal year that ends New Year's Day, so that means money's got to be spent. The Swedish Transportation Administration, STA, is the end user of somewhere between 40 to 60% of the total market. So we are the big funder for a lot of the projects. And we also use about 10 to 15 million square meters of chip seals. So that would be closer to 15 to 20 million square yards of chip seals, quite significant. And we also use 1 million metric tons of soft asphalt mixes. That is mixes that is very soft. We are in the penetration system, as most of the Europe still is. We're not using the performance grade system, but we look at it. So we typically have numbers for our binders used. A typical binder in Sweden would be a 58 minus 28. That is a typical binder. High performance binders, PMBs, probably somewhere in the range of 3 to 5% of the hot mix market. So it's not a high number, but with the number of maintenance activities for those crash cable lanes, we really see significant improved performance where we use polymer modified binders. We also use performance-based contracts in some cases, and it's about 15% last year. I think this year too. Performance-based, that's a different way instead of recipe-based contract. We also, and here is I think the big difference from Europe versus America. That is that we have a full responsibility for the contractors. So no inspectors on site. We might have spot testing done, but contractors have full responsibility, and there's a warranty of a minimum of 5 years on all the contracts. When it's performance contracts, it's very easy to say that well, of course, we're going to measure the performance over time, so that is in the contract. But when it's a standardized contract, we have a warranty procedure for that. And the warranty differs from the way the warranty has been introduced in the US. So, but that would take another lecture to let you know all about our warranty systems. So that was a little in brief about the road administration and the transport administration and the Swedish market. So if we look at this performance of the flow mixing technology, that is a different technology. I want to acknowledge also the company KGO Mixing, where the inventor, the scientist about this, his name is Carl Gunnar Olsson. So that is the acronym for him. But also VTI for doing a lot of the research stuff, helping us to evaluate the performance of these roads. And to explain to you a little bit about what is the flow mixing technology. It is a technology to produce asphalt concrete mixes with same or better quality without use of extra additives. It's a technology where you can reduce temperature also. It has to be reduced without introducing an additive for that or foaming. So it's a warming technology, but this was developed way before warmix. So it's through a controlled way of production. It reduces variable sources of raw materials, saves energy, and give long-lasting products. And it's, I should say, this also is a patented process, and it's been licensed to all the contractors in Sweden. What he does outside Sweden, I'm not really sure. I think there's patents also in the US and in Europe, and I'm pretty sure he wants to get people on board with it. But this procedure, before I show you the process of it, it also, as you will see, requires either a batch plant or a very reconstructed drum mixing plant. So, but with a batch plant, and batch plants, they're 85% of the asphalt plants in Sweden, they're batch plants. That's the difference from in the US. I think it's almost the opposite. So, the flow mixing method, the principles of mixing here is that we have a, let's see, can we? This one is not supposed to start until well, it does. I'll back up later. You know, when you sieve the material in a batch mixing plant, you can split it into a coarse fraction, you have binder, you have filler, and you have fine fraction. And well, is this self-running? Shouldn't be. So when we introduce this is to have the coarse fraction, drain it with the binder, all the binder in there, put filler in a controlled way, distribute it evenly, and makes the whole mix swell. And then we introduce the fine fraction rapidly. And that's basically mixing until black. So that is the principle. And to illustrate this principle, we start with the normal mixing procedure in an asphalt plant is to have all the dry material added at the same time to the mixer. There are small differences in that, but basically that's been done. You add all material, you mix. Oh, sorry. Let's do this. And for you online, it was only the sound that went. I'll rerun it. Hope everyone can hear the sound now. So we add all the dry material, and in this case we also use water instead of as a liquid instead of a binder, so you can see what actually happens. And mix. And it's my hands, so I'm not telling you this is anyone else doing this. This is me. So I've done it. I'm still married. So mixing until everything is mixed, and then we pour it out. And so that was the paver, and here comes the compaction. And so we compact it. And then we use this different technology. Then we add the liquid first, because we don't have a coarse fraction. Add the fine fraction to it. Mix, so all the fine fraction and water distributes evenly, and then the fine fraction quite rapidly goes in and makes around. And then I pour that one out next to the other one and hope that you will see a difference. So let's pour that one out. And it's important to state this, that it's the same amount of materials, no difference there. And we compact this a little bit, hopefully. And this test can be repeated. So when I recorded this, I repeated it twice, but you can repeat it, and it's a really good learning curve there. So this is a comparison between these two, non-compacted. That one, well, acting the way it should probably, and this one is acting strangely, because it's only water and materials. And can you see a difference of these two? And those are under the same conditions. So again, the principles of mixing: coarse fraction, binder, the filler, the dust particles, they go in, makes the swelling, and then we add the fine fraction. So And I don't know if there are any questions about how the method is done, or no. So I'll go on and show some examples from the real roads. When you're out on a paving site looking at this, we were fascinated, and we took some material from the side of it. When you look at it, it's got a characteristic low, and that indicates this thick film, the film thickness here, the coating, and that you also got the particles distributed evenly. If you compare it and we look at the test section, this one has 7,000 AADT, the traffic amount, 10% heavy trucks. When it was new, a year later, and this is after 8 years later. It's pretty much the same surface. Very interesting project. And what we've seen with this is that by using observations and testing, is that we gotta control the temperature. If we raise the temperature too much, we will have bleeding issues, drainage issues, drain down. And we also might destroy that thick film thickness. So we don't want to do that. In the top layers, the wearing courses, we use binder-rich layers, and probably richer than you do here. We found that we need to decrease the amount of binder because it's too much of binder. So we decreased the amount up to 0.5 units. And we also see better homogeneity. And the asphalt mix is more sticky and have a lot less visible segregation. So you can't see really where the trucks left the paver. There's a test method, well defined as test of dispersion, I think that was the KGO himself that named it. But it's a way of verifying that the product is really working and that it's been produced the way it should. And you can test it both in the laboratory and with either from the asphalt plant or drilled cores from the road. And this is really the key to ensure quality, because otherwise what we did as an agency was that we had contractors perform, because we are only buyers. We don't have any equipment ourselves. We don't have any laboratories ourselves. But in order to know that they use the method, we described it, we paid them extra money to use this method, then we needed to know that they actually used the method. So this was the way we could control it. In a base layer, where the maximum aggregate size was 1 inch, so it's a very coarse mix, we could really see this different visibly, that the binder is used more efficient in that mix. We've tried this on a number of different mixes, on a number of different binders as well. And we've tested all these different parameters. And one of the interesting things, especially if you lower temperature, if you lower binder content, is the freeze-thaw test and salt water test. And we have a special test for that one that is used in research called the winter conditioning test that VTI does. And they have a limit of 70 for saying that this is a good performing mix. So when we looked at all those with the KGO method, and I think the slide has jumped a little bit, from this side, you can see that this is 2002 values, this is 2005 year. So with 3 years difference, the reference increased a little bit. The KGO, they're performing really well. This one, although, had a decrease after 3 years. This one is, what's special with this one is that this is the test section where we first introduced any wrap. So can you use this method with wrap? Yes, you can, but what we found was that you gotta have the wrap introduced with the coarse fraction, and you gotta add mixing time to get the temperature in the wrap up. And this wasn't done. This was the first test of it. That was the test section. What was interesting was that this test tells us that this road should fail before the other tests. So, and they're still performing these roads, but that section, this road, that's the only one that got a lot of cracks in it. So this one is the one that's going to be maintained first. Well, maintenance activities on it before all the others. And we're still evaluating, because it's interesting to look at roads now that they're 10 years old. So that's what we're doing. You had a question?
What's actually being measured in this plot?
This is the indirect tensile strength test. So it's very similar to the Lotman test, although this is cord samples from the road, 5 samples stored dry, 5 samples conditioned. But instead of cracking the specimens, this one is stiffness values. So, but we also used surface characteristics measurements. So we had a laser van going out there measuring rut depth and looking at that, and we don't see any significant yearly increase of the rut depth when we use this method. On the other hand, it could be beneficial. This is something that we really want to look, now that the roads are 10 years old, we need to look at this again. So that's been done right now. The environmental effects, they're quite significant. We have produced 600,000 metric tons so far since 1999. We have a 4th generation specification for it. And it's important to state that because you got to make sure that you know what you're doing. This was research from the beginning, and then when you implement it, you want to make sure that it works. You got to be thorough with the specification as well. We have published a lot of reports, but unfortunately in Swedish, all of them. I hope that we will translate at least the latest report into English when it's finished, and that will be beginning of next year. Just a few pictures from other roads produced with this method, and also you can see pictures from, well, just maintenance activities on roads, typical roads in Sweden, pavers. This was a high-profile project where we have a lot of traffic. Those wake-ups, you have those as well, wake-up lines. Or we also introduced rumble strips in Sweden. We have a lot of them now. That road was paved 2005. It's got 18,000 AADT in each direction, so it's pretty heavily trafficked for being such a narrow road, and it's still performing. Some main concerns about this method. Well, I mentioned the batch plants. Old asphalt plants may have a reduced production rate because of this mixing sequence. Of course, dissemination of know-how. It's not easy to learn this. And it's also very difficult to perform this procedure in the laboratory. And some adjustments, such as gradation as well, AC counting may be out of spec. It might be not allowed, but when we produced it, it still performs and really well. So this might be the greatest hurdle to actually to try to get over, which is the not invented here syndrome, the reluctance to try, that people don't want to try it, don't want to see it. So I've spoken about the advantages, the segregation, the deformation stability I haven't mentioned, but it's by rough depth if you look at it, and if you look at for the test results we have, excellent performing. I've come across a few tender zone mixes, especially here, but this mix is doesn't have a tender zone, and it's known. It's got years of good performance, and we can also quantify the environmental effects of it. And by that, this is the last picture of KGO method, flow mixing method. Any questions about that? Interesting, or? It's quite different. It's a different way of looking at it. And when I've met people that when you go to conferences, that when you say that, well, we've looked at the mixing technology, then they're quite interested because it's not that well covered. You know, that the how to mix, that was defined back in the 50s. So, yeah.
I have a question from our online people. They are asking, what is the typical binder content?
Of an asphalt mix in Sweden, of a wearing cost would be 6% asphalt content by weight. Yes?
Do you have any reason that why this kind of mixing technology is producing mixes superior to the conventional ones? Do you have some physical reasoning to justify this?
No, I think that basically it's that thick film thickness that helps the mix, and the compactability of the mix. We use quite low air void content of the mixes. They're in that range of being perhaps 3, 4, 5%, but not above 5%. That helps the mixes. Helps keeping the water out also from mixes.
How about the reaction in Europe, other than Sweden? Maybe it doesn't come here yet, but how about the other countries in Europe?
In Germany, they are having, I think they have 1 or 2 asphalt plants modified to produce with this method. There's been a lot of interest, but very few plants rebuilt to produce with the method. So I think it's spreading now, but it's still going pretty slow. I'm not sure about war mix technologies when you come with a method that doesn't include a additive, doesn't include water, foaming. So I'm not sure everyone is happy about it. But the business layout is very simple. So we paid a fee of less than $1 a ton for the license. So that was basically to cover his expenses for the patent. And then the business idea is that the contractors actually should make money out of using this method if we get the extended technical lifetime. That would make a win-win situation. So
what about the mixing time compared to the typical one?
Well, you increase the mixing time, perhaps 10% longer mixing time. If the plant can adjust the size or weight of mixes, you won't have a production rate that is going down. But since the plant is already having their drying drum in the same, and sieving and all that is going the same speed, but there are limitations to all the asphalt plants in the batch size, and that this mixing sequence that is a little bit longer, that is reducing the production. Okay, should we move on to next? Because this is a presentation I made very recently. I went down to Munich for the World of Asphalt Rubber conference. That is an international conference. It was 170 participants. And that's why I also have the translation of the Swedish Transport Administration in German here. I didn't mention this before, but the vision for the Transport Administration is that everybody arrives smoothly the green and safe way. So, and here another picture of where Sweden is in Europe, if you look at it. On the sides here, let's see. We see Norway, we see Finland, we have Denmark here, the Nordic countries, we have Iceland over here. And I also pull up some facts about hot mix production. If you look at, in Sweden, we produce 8 million tons of asphalt mix a year, approximately. Europe, it's 310. In the US, 327. And I should say that those numbers, they're reported by NAPA and IAPA. And if you look at this number and you go back just 2 years ago, well, 2 years before, these are numbers from 2010. So at 2008, it was 500 million tons in the US. So the economy downturn really hit the paving industry in the US. We've spoken about challenges and the traffic, but the asphalt rubber, it's a new concept for road pavements in Sweden. It's not a new concept, but it was for us. And we started a project 2007 until 2009, a 3-year project that where the road administration at that time was the main responsible part. And that meant that we took the responsibility of what the contractors produced when they produced asphalt rubber. And we also rented in equipment to produce and staff for it, and we tried to produce asphalt rubber in the best way we knew. From 2010 and ongoing, we have a continuous study of produced test sections, and we also have continued implementation. And we also are in the situation where we put the responsible part to the contractors. So when we introduced it, we took the responsibility. Now we've proven it. We've proven it for the industry. We want the industry also to be a responsible part. And the focus for us, this is really important, the focus was implement something already existing technology. This is an innovation that is proven to work elsewhere. So we didn't want to invent the wheel again. We really wanted to use it the way they do it in Arizona, but a small but. We had to tweak it into our Nordic climate conditions. Since we have studded tires and they don't in Arizona, we needed coarser aggregate. We needed to do a few adjustments, but only a few. The main objective is the increased technical lifetime, and that will give us reduced annual costs. So life cycle cost will decrease. We also saw environmental advantages, the reduction of noise as one, and reduction of particle emissions. Particle emissions from wear, from studded tires, that could be some. Also less wear. And some about the increased traffic safety, better skid resistance, less splash and spray. That was reported in the literature and on other projects. The follow-up work focused really on the more of the technical lifetime, and we've also had some we have had some studies of this reduction of particle emissions that is promising. Asphalt rubber, the good stuff. This is a very short video clip. This is what it's all about. I'll show it once more. A binder that has excellent properties. A quick history in brief here. Back in 2006, it started with a literature study. We went to the US for education. We went to the Asphalt Rubber conference in Palm Springs, California, learn about asphalt rubber. And we decided to implement the wet technology. Back in the late 70s, in the 70s, we had dry mixing of crumb rubber as a technology used by one of the contractors in Sweden. And they had great success on some of the roads, and also great failures on some of the roads. And this is a main obstacle why people won't use asphalt rubber. We had the same situation in Sweden. We had to convince ourselves that, well, the wet technology is engineered. We got to control this a lot better than we could with the dry technology. There's obviously a lot of environmental concerns when it comes to crumb rubber, when it comes to using old tires. And so we decided to do a lot of environmental studies. We rented a binder blender unit, and we produced the first test sections. That was 2007. 2008, we continued more test sections training, and we have also important to point out, we had a failure with one of those low noise sections. And when this failure happened, it was basically an open grid mix where we had construction issues. A month after open for traffic, it started popping rocks out of the mix, out of the surface. And we saw that it was more than one. It will go on. This was a failure. We decided to mill it off. Not trying to save it, not trying to keep it there. We milled it off, and we put another surface down with a different pavement. We didn't want it to, because that one could really destroy a project if you put something down that is not comparable, but it's still having the name of something new that you're testing. So we took that one away, and I think that was good. We learned a lot from that. 2009 Swedish specification, a tentative specification. We did more test sections. We went out, produced it on high volume roads. And 2010 we had an international conference, and we also ended the first part of the project. We ended the project that started everything. And it's important to end projects, because from there you can be successful, and then you can do a follow-up project. So we started a new project in 2010 at the same time, called it second generation, and with focus on more low noise sections and follow-up work. Last year we tried to introduce asphalt rubber in really cold climate with dense graded asphalt rubber. And we also produced thin layer with asphalt rubber. And we saw that the capacity problems on this blender unit really was a problem for us. In 2012, this year, we put out for bidding an innovation contract about the asphalt rubber blending service. We also tried something we call 50-50 evaluation bid, where the contractor in the tendering process leaves two bids, one with asphalt rubber provided with the blender unit, and the other one without. And the average of those two bid sums is what you compete with. This gives us, as an agency, the opportunity to choose, but it also gives us all the contingency things that can happen. So we had that opportunity. And it also was good for the contractors. They haven't complained about that, because it's very clearly stated that we buy the average of two bids, and it's still the lowest bid that wins. We also produced test sections or in 2013, next year, we will produce test sections with warm mix technology. And we want to continue this with the 50-50 bids, and we want the contractors to be encouraged. And by 2014, we think this is going to be an established product, put on market, where we can buy it wherever we need and want it. Some of the sections you can see here, from southern part up to the northern part, and several sections of these at the same location. I spoke a little about the environmental restrictions. We have a chemical agency that wasn't too happy about us putting from rubber into asphalt. We explained to them what we're doing, how we control it, and after a while they were really encouraging us also, and thought that, well, control this, and you're okay with it. There are technical possibilities for production that needs to be overcome. Well, CE marking, you don't have it here, but we have it in Europe. Every equipment has got to be CE marked, basically saying that the workers, safety equipment and the workers won't be harmed by the equipment. There's also a hookup issue to hot mix plants. You need to, every hot mix plant might be different. It's unique, so you got to have a unique hookup system for it. And of course, the contractor's got to be willing to pay this. So, and the crumb rubber supply, we had to buy crumb rubber from outside Sweden, but now we do have a manufacturing unit that can sell us crumb rubber. Of course, mix design and laboratory work, things that you do here. It's really important. You can't put mix out there unless you control it. You got to know what you're doing. And of course, work is surrounding, fumes and smell. Asphalt rubber, it has a different smell. So you got to prepare for it. You got to know what it is. If you don't know what it is, you might have a real issue with it. If you know what it is, we haven't encountered those problems. I stated that the focus on implementing already existing technology, and that in that we also had the ASU help us to do the evaluation of our mixes, so they could compare. And they're thinking we're putting pretty tough mixes down. They like what they see. VTI helped out a lot. We have also the contractors' laboratories, and we have used Swedish and European standards for testing. But also, we've used the US standards when it comes to testing that the ASU performed for us. Results, they're promising. We will see this in the reality, but the test sections right now, they're looking really good. We focused a lot on these environmental related studies, and every worker, not every time, but every paving site has at least one measurement done about the workers. So we test every paving site right now. And what we've seen is that the PAH is far below limiting values. Most of the time we can't detect substances. Weather conditions have influence on the air quality for workers. So if the temperature is high and the wind is standing still, then we have more of readings. We also looked at the asphalt rubber binder increased, if it has increased leaching, and we have found PAH and creosoles, but those are low according to limit. And this substance benzoyazole, that is what we can see, and that is what's giving the rubber smell. And that one, it was classified as no acute toxic effect, but it's been very hard to detect benzoyazole on the worker's site. Particle emissions, we all got lower emissions from that. And we have a new worker study that is the union part. They're funding a worker safety study at the University of Lund that is going to do a lot of different testing. And what's interesting with that study is that they're going to compare asphalt workers, normal population, 100 workers, working with reference, with 100 workers working with asphalt rubber. That's where our problem started, because we could find 12 this season that was working with asphalt rubber. It's not that big of a project. But they want 100 each season to compare to each other. Asphalt rubber, reference only asphalt paving, and then compare to people working in gardens or a reference group not working at all in paving industry. And that's going to help us give us information about what it is like to be working on a paving site. The interesting part is also that Germany has shown great interest, and they have a different asphalt rubber technology with the dry process. And I really want to see what the comparison between reference worker in Germany and reference worker in Sweden. That would be great to see that. Also, of course, asphalt rubber, but I think just that what might help the industry to promote itself. Asphalt rubber production so far, 110,000 tons of mix. It's more than 100 kilometers. That would be 60 miles. Am I correct? Yeah. Of test sections, something like that. 25 different projects. We have used more than 2,000 chrome rubber granules. What we've seen is that we can produce asphalt rubber with, as expected, good quality. We can control the environmental issues. And we can't see the negative impact. Workers' health can also be managed, especially if we share information. And we also have in our specification a maximum manufacturing temperature that is not allowed to be exceeded, because then you have increased fumes from it. And we also have a technical specification. So it's definitely a concept for Swedish roads. In any project, this is in any project, a word of advice. A successful project can be achieved if do your homework. Do your homework properly, investigate, get know-how. That's how you be successful. And also you got to make a plan for the project and get funding, of course. It helps to have skilled personnel, but you also need champions. We had a really good champion in this project, the project leader Torsten, and he's been an advocate for this, and he's really knowledgeable, and he knows what he's doing. It's also important to manage your risks, see the opportunities. In any project, there's got to be risks. And maybe the most important part is share your experience, because then people can ask you even more questions, or you might have other inputs. Share your experience, really important. And by that concludes the second presentation also. Thank you. And maybe you have a question or two about the asphalt rubber project? Yeah?
Aaron was asking, is vodka production of Sweden?
Sorry?
Vodka, is it a product of Sweden?
Absolute Vodka is a brand from Sweden, yes. It was produced in Sweden. You know it. Yeah.
Yes, I have a question. What's the standard axle load right now in Sweden? I know you were switching, or you probably have switched already.
No, standard axle load is 10 tons.
It's not 11.5?
11.5 is the front load on the trucks. So 11.5, but it's really the 10 tons that we do all the design work from. Yeah. Yeah.
I'm actually quite surprised that you elected to go with the wet method rather than the dry, because it seems like the dry would better complement the flow mixing of your first presentation, would it not?
So far, these two methods has not been used at the same time. So maybe you're correct there. But in asphalt rubber, you have, I didn't say this, but in the technology there, you have crumb rubber reacting with the binder, and you have a swelling process, and you gotta control these. Some people call it cooking, or that you gotta control that procedure, and that is what's been the main failure in the dry mixing process, is that you have trouble to control this swelling process and this viscosity of the mix. So you want a mix that is possible to work with when it's on the laying site.
Were your wet method products actually considered terminal blend materials or not?
No, they weren't considered terminal blend because we're above the amount of crumb rubber of 15%. We've been closer to 18, sometimes up to 20% of crumb rubber in the binder. Binder versus neat binder versus the crumb rubber. So we've been at that range because we didn't want to produce just a polymer modified binder, because then we can buy a standardized product already. I know that here in the US a lot of the discussion has been that SBS polymer the price is increasing. It's been a shortage of supply for 1 year, and then the crumb rubber would be a substitute for it, and then you would go maybe for a terminal blend or something, and you can do a modified binder that still meets the specification. But that wasn't the case in Sweden. We wanted to really try to enhance the properties of the asphalt mixers.
Additional line was how fine the rubber is ground.
Yeah, less than 1 millimeter. I'm not sure what that will be in mesh. Or 1 millimeter, is it 0.04 inch? Yeah. It would be beneficial to go for a little bit coarser grind, but then you would have more of that controlling the swelling, controlling the reaction problems. But those especially if you go for low noise properties, that would help. But risk of failure is greater. So everyone see what's on the picture? Vodka you identified. ABBA you might know of. The Swedish, well, sometimes people say Kingdom of Sweden. We are royal. We still have a king. And last year we had a baby born. The year ahead of that, our crown princess, she married, I would say almost like a farmer's boy or something like that. So that was a fairy tale story, covered by all the news network all over the world. So. Midsummer is big in Sweden. IKEA, you've heard of. And I went to IKEA when I traveled here. Pippi Longstocking, a lot of people don't know that Pippi Longstocking, you've heard the stories, the books of Astrid Lindgren. If you have kids, those are great stories. Volvo, of course, and H&M, Swedish. So, and that's only a picture from summertime also.
You have Zlatan Abramovich too.
I didn't hear you.
You have Zlatan Abramovich, the soccer player too. You put it there.
Oh yeah, oh yeah. Quite you know, it was just a week ahead of the conference in Germany. So when I went there to Germany, and you know the expression, don't mention the war. Don't mention Ibrahim. Zlatan Ibrahimovic in Germany. That would be bad. They lost. Yeah. Thank you.